Yeah, the sine inverse. So we're sine inverse in this value. So we're just going to put, now because it's orange, we have the second function. Click the sine and sine inverse comes up. Then we just type in our value, 0.8297, 62. And then we just put our 6.8 degrees. And that's basically it. Now, the same process applies for cos, it also applies for tan, right? So we'll now work this problem. Now, because I've explained before, I'm just be going through it. Now, we're given our hypotenuse, 21.4 cm. To give my handwriting, our angle is 60 degrees. But which side? Why? Why is which side? I represented the hypotenuse as capital E, and I've been using hype before. Y is, it's not our opposite. If you remember, 60 degrees here. This would be opposite of 60 degrees. It's not the opposite, it's the adjacent. Now we have the adjacent and we have the hypotenuse. I'll, I'll just write the trig ratios here for remembrance. Tan equal. Now cos deals with adjacent over hypotenuse, since we have the adjacent and the hypotenuse. So cos of our angle is equal to the adjacent y over hypotenuse 21.4. And similar to the steps in sine, we do the same thing, right? But instead of sine, we're using cos of 60 degrees, which should give us 0.5, right? Then we go on to 21.4. This gives us 10.7 is equal to y. We now move on to another example. So forgive the handwriting, this is 13.9, this is 8.4. So let's write what's given. We have our hypotenuse, it's equal to 13.9 cm. We have our angle y. We have our adjacent side, since this is the side where both angles lie on. This is the opposite of y, but this is the adjacent. So we have the adjacent, 8.4 cm. And now the same process applies. Since it's adjacent to our hypotenuse, we use our cos over angle y is equal to our adjacent side over our hypotenuse. Input 8.4 divided by 13.9. So again, at least 4, 0.6043. And when we transpose a cos, similar to sine, we get the inverse cos, inverse of 0.6043, right? So the cos inverse is generally above the cos button. So the second function, cos inverse, and then you type in your value, 52 points. So y would equal to 52.82 degrees. Now move on to our final two examples. We'll now look at the example above. Again, what is given? Now we have our angle equal 57 degrees. We don't have a hypotenuse. So don't always just put hypotenuse. You have to observe the triangle first. So we have our 57. We have a side opposite of 57. So we know that we have our opposite side 13 cm and the S now 5. I know it looks like 5, but our adjacent side is equal to S. Now, which ratio uses adjacent and opposite? Tan. So, the tan, or angle, is equal to opposite over our adjacent side, S. Right? Now, this again is solving an equation, just in knowledge of solving an equation. Now, we'll tan the 57 first. Now, tan represented by Tn. Use the 4 digits, decimal places, at least 986. I use 5 to avoid all the rounding. Is equal to 13 over S. Now, generally people don't know how to transpose and then they get the wrong value because they would say S is equal to 13 times 1.53986. Now remember, our S is in, our unknown is in our denominator. See, you can't just times it, right? This is what people generally do. Just multiply the 13 by the, because the S is divided. No, you have to do it in steps. It seems complicated, but it's not. Before you solve anything, if you want to, if what we're looking to solve is in our denominator, in for instance S, we first need to get it out of there. Now this is a transposition, a crash course in transposition. Whatever we're solving for, we don't want in our denominator. So how do we get it out? Well, the way we best know to do it, carry it over the equal sign. So S is being divided here. So when we carry it over, it becomes S multiplied by 1.53. Right? Now we have what we want out of our denominator. Now we want S by itself. Now we just transpose what we don't need, 1.5. Right? And the 1.5 is being multiplied over here. So when it comes over, it's being divided. Right? 13 divided by 1.53986. Sorry, not 1. 13 divided by we get 8.44. Now, in this case, our unknown is in the denominator for a tan problem. This can happen with sine also. If you given a problem with sine, this can also happen. So, for instance, this is a problem with sine that where an unknown can happen in the denominator. We didn't do an example with it. And cos, right? Make up random stuff. 5. So we do x 4 say 45 degrees, right? No, not I won't use that one. Yeah, we use this one. This is just an example where our unknown could be in the denominator. So find x, right? Again, crash course just to get a point. So opposite side, I get sine 45 is equal to over hypotenuse x. So this is an example of a sine problem where unknown could be in the denominator. The process would also remain the same. I think sine 45 is 0.707. Let me just check. Right, yeah. So when we sine, we get 0.7071 to 4 of x. And we would solve it similar to how we did here. get our unknown out first, and then we carry over. So that's basically how you solve a problem with the unknown in the denominator. Hope you guys understand. Now we shall move on to our final example, this one here. Yeah, so now our angle given is equal to x. Opposite side, the side opposite x is 8.6 cm. Now this is not our hypotenuse, this is our hypotenuse, but the side here would be our adjacent. 12.8 cm. Now tan, these are opposite and adjacent, so tan or angle x is equal to 8.6 cm over, you can plug this in your calculator and we get 8.6 divided by 12.8, 0.671875. Now similar to cos and sine, when we transpose a tan, we get tan inverse, right? And just like cos and sine, also the tan inverse is located above here. So tan inverse, let me just put in our value, 0.671875, and therefore we get x is equal to 33.9 degrees. And that's basically the trigonometric ratios, trig ratios. Basically, you're just observing a right angle triangle, picking out the sides, knowing which ratio to use, and then finally solving for your unknown value. That can be it. Any questions, y'all send through on WhatsApp, whichever you know to get me, and I can try to answer it. Now also, work the problems. Use the time to work the problems.